Good day! In this video, we are going to try and solve question 1D of the 2023 calculus paper, level 2. And this is the title of the paper is called Apply Calculus Method in Solving Problem. This is an excellent question. It's a word problem and it's a maximum minimum type of question. So without further ado, let's try to solve this question. Okay, the question sounds like this. Okay, so a school is making out a 400-meter track on its field. They want to able to use the infield area, I mean the rectangle between the two semicircles, to run PE games and activities. Due to this, they wish to maximize the rectangular area enclosed by the track. The track must consist of two straight sections and two semicircle sections and must be 400 meters. Three examples of the fields are shown below. So it could be this shape, or this shape. So you have a straight line and a two semicircle. Okay, so find the dimension of rectangle that maximize its area. Remember, so the area to maximize, use calculus method to show that this is the maximum, and the circumference of circle has the formula C equals to 2 pi r. Okay, so before we start, we're going to just choose one of them. So we're going to do this, a common shape, which is going to be this because it's quite easy. So suppose we let the length of here to here is x. Okay, so this, we are interested in the rectangle. So if this is a semicircle, okay, if this is the radius, okay, so this part here is going to be 2r, because 1/2 of it is 1 radius or 1 diameter, so radius become 2 radius. Okay, so we're going to form an equation. So the area of the rectangle thing, okay, area I'm going to write here, area is going to be x times 2r. Okay, so because area is length times width, so x times 2r. Okay, so because they talk about a perimeter of 400, because it must be not more than 400, so we need to find the perimeter. Perimeter is equal to x plus x, so it becomes 2x, and then the diameter of the circumference of the two circles, half a circle, and one circle, is going to be plus 2 pi r. That's the circumference of circle. This plus this will become the circumference of the circle. That is 2 pi r. Okay, so now we are going to use this formula to make use of the 400. So perimeter is 400. Okay, it's going to be 2x plus 2 pi r. Okay, so now what we're going to do, we're going to simplify that equation by dividing by 2 throughout. Okay, we're just going to put this in front. So x plus 2 r equals to 200, because we divide by 2 and we just put this part to the front and this part to the back. Hopefully you got it. Great. Okay, so now we are going to simplify in terms of x. So x is going to be, divide by 2 pi r, not 2r. Okay, pi r. Okay, when 2 pi r divided by 2 is pi r. Okay, so x is equal to 200 minus pi r. So that equation, we're going to use that later on to substitute into another equation. So remember, important equation, x equal to 200 minus pi r. Okay, so now we are going to substitute the area formula. A equals to x. Instead of x, we're going to replace by 200 minus pi r times 2r. Okay, so now we're going to simplify that. Okay, 200 times 2r is going to be 400r minus 2 pi r squared. Got it? Great. Because we are talking about minimum, maximum point, we need to differentiate the area. So dA, I'm going to continue dA over dr. Differentiate that equation. It's going to be 400 minus 4 pi r. Okay, so you bring the 2 down. So 2 times 2 is 4 pi r. Okay, so for any area, or turning point, so dA for area calculation, dA over dr have to be 0, or turning point of 0. So we're going to solve your r. So 0 equal to 400 minus 4 pi r. Okay, now we're going to plus 4 pi r on both sides. So 4 pi r equal to 400, pi r equals to 100, okay? And we're going to substitute r equals to 100 over pi, okay? So we're just going to, in terms of r, we're going to put it as 100 over pi. So to find the maximum area, okay, so what we're going to do, we know that the area is x times 2 pi from that equation, okay? So area, so x, No, we're going to use this, okay? This equation. So x equals to 200 minus pi r. We found it because we're going to calculate x, maximum of x, okay? So now instead of r, we're going to replace by 200 minus pi over 100 over pi, because r found at 100 over pi. The pi will cancel out. So 200 minus 100 is 100 meters. So the maximum length or x to be calculated is going to be, to get the maximum area, your x have to be 100 meter. If you can solve this, that's excellent in this paper. And hopefully you go through this again and it should be all good. Cheers everyone, have a good day.